In this episode of Scaling Postgres, we talk about a CTE warning, Postgres 11 features, death by database, and column correlation. I'm Preston Jameson, and this is Scaling Postgres, episode 31. All right, I hope you're having a great week. Our first article is Be Careful with CTE in PostgreSQL. And this is from Hakai Benita. Now, a CTE is a common table expression, which you could also think of as the with clause. So it's basically taking a subquery and putting it earlier in the statement and being able to call it again. So he shows in a simple example of one here with CT as select all from foo. So CTE is what he's named it. And then he can then do select all from CTE where an ID equals something. Now, what he's saying you need to be careful of is a simplistic example here where he has a foo table and he's looking up by an ID that has an index on it, and that lookup took less than 1 millisecond. Whereas using a CTE, of course, you're defining all the records in foo, so that is going to take a while. But then you do a select all from CTE where the ID equals the same, and it suddenly takes 227 milliseconds. So basically what's happening here is the CTE kind of materializes what you're asking for, basically caches it, and then can use that query again. And it's not, for example, pushing down this ID into the CDE here. It's essentially materializing this part that you've done. And he references some things from the docs, where it says, quote, a useful property of with queries is that they are evaluated only once per execution of a parent query. So basically you could use that with query multiple times and it's not going to re-execute it. But again, the quote says, however, the other side of this coin is that the optimizer is less able to push restrictions from the parent query down into a with query with an ordinary subquery. And again, with the explained plan, you can see where just the simple query looking for a particular where ID is using a index scan. Using the CTE example, it actually has to do a sequential scan. Now, unlike a CTE, just using a basic subquery, so select all from and then do the subquery here, select all from foo, where the ID equals that, it is able to push that down. So you can see it does do a sequential scan in this case, and you get a query response of less than a millisecond. Now he also mentions Oracle actually looks different in that it is able to essentially inline the CTE and give the same response time whether using it as a CTE or a subquery. In quote, Oracle is not materializing CTEs by default. So basically this is just a decision that PostgreSQL has adopted that you just need to be aware of, that it does materialize its CTEs, and because of that, it can't push down predicates into your CTE from the parent query. And if you're needing to do that, just use a subquery to do it. So it is a warning in terms of you should understand how PostgreSQL works. And this was a great post that goes through it, and I encourage you to check it out. The next series of posts all talk about features coming in PostgreSQL 11. And our first post is PostgreSQL 11, Something for Everyone. And this is from the lwn.net. And it's an article contributed by Peter Jogagian. My apologies on that pronunciation. But this article goes through a lot of the major features of PostgreSQL 11 and a little bit of the background in it. So of course, some of the biggest features are the partitioning changes. And we'll go into some additional articles and talk a little bit about this more in detail. But I thought this was probably the best article to read about some of the upcoming changes and the reasoning behind it and why it's happening now versus not earlier and things of that nature. But it goes over the partitioning improvements, parallelism improvements, just-in-time compilation of queries. And again, based upon my understanding, this is something that you need to enable when you're actually building from source. So for example, using the -- with -LLVM flag. There's the introduction of procedures, so not just functions, but procedures where you can actually do commits and rollbacks within them. the introduction of covering indexes. So you can add additional columns to an index that doesn't necessarily index by it, but it includes additional columns in essentially the index payload so that you can increase the number of index-only queries. And this is a great one here. The instant add a column with the default value. So not having to rewrite the whole table. So again, I definitely encourage you to read this if you're interested in a lot of the new features. The next post highlights some additional features, but it's a little bit shorter of some things that were notable to him, and this is Postgres 11, a first look. This is from the Craig Kirstein's blog. Number one is quitting Postgres. Typically you had to do a /q, but now you can type quit or exit. So this is great for new users to using Postgres. And then a headline, fear column addition no more. Essentially, this is where adding a column with a not null and a default essentially had to rewrite the whole table. He talks about performance improvements, going back to the parallelism, and he's highlighting the capabilities of doing a parallel hash join, capabilities of doing parallel append, and I believe this comes in cases where you're doing a union and have multiple select queries. It can parallelize that, as well as parallel index creation, which again, that's a great improvement. He mentions the just-in-time compilation that's possible. And he also covers creating statistics, which wasn't mentioned in the previous post, but with 10, you could start defining multiple columns that you can create statistics across. But with Postgres 11, now you can create statistics based on expression indexes. And lastly, he mentions some improvements with PG_prewarm. So again, another post talking about the new features coming in Postgres 11. Now, my understanding is that Postgres 11 is due to be released essentially any week now, and they just released beta number 4, so it's definitely going to be released relatively soon. The next article is actually a PDF of slides that were given as a talk. Again, the title is Major Features, Postgres 11, and this is by Bruce Momjian. And again, he goes over, the partitioning improvements, the parallelism improvements, the introduction of stored procedures, the executor stage compilation, which basically is the just-in-time compiler, preventing table rewrite for alter table add column with non-null default. Again, that's a huge one for large databases. He mentions finer-grained access control. So there's some additional access control features that have been added you can check out in this presentation. In addition to some write-ahead log improvements, I believe this is where you can actually increase the size of the wall files that are being generated, which may be helpful for larger databases. Again, he references the allowing the quit and the exit when you're going to be exiting PSQL. So again, this is about 24 slides worth of information, and if you're looking to learn and understand more of what's coming in Postgres 11, definitely another piece of content to check out. The next post is why covering indexes are incredibly helpful, and this is from the Crunchy Enterprise PostgreSQL blog. And essentially, this is talking again about a feature that was mentioned in the previous piece of content, but it's dedicated to covering indexes. This is where you're adding additional columns to an index. It's not indexing on that column, but it's an additional payload so that when you use the index, that data can immediately be used. It doesn't have to go to the heap to pull additional data. So essentially, this increases the amount of index-only scans you can have without that data exactly having been indexed. So this goes into detail about that and gives a very practical example of using it. So if you're a developer and potentially interested in this feature, this is definitely a blog post to check out to learn more. The next post is Partitioning Improvements in PostgreSQL 11, and this is from the secondquadrant.com blog. And again, this just goes into more detail of the partitioning improvements that we've discussed. So just to run those through quickly, PostgreSQL 11 is introduced hash partitioning. So if you don't have a natural key to partition by, this allows you to just use a hash to do it. Update can now move rows between partitions if it needs to. Insert on conflict update now works across partitions or for partition tables. And you also have support for a default partition in a partition table. So if a partition table is not necessarily targeted, data can be placed in a default partition. better DDL support, or basically easier to work with partition tables for DDL commands. So for example, you can use create index on a partition table, whereas you used to have to do them individually. You can do create unique constraints as well as primary key constraints, as well as a partition table can have foreign key constraints. And then he talks about the performance work. In terms of pruning the partitions in version 10, that only happened at one stage, at query plan time. However, with 11, with some improvements, it can now do this type of pruning at query plan time when the query parameters are received, as well as at each point where one query node passes values as parameters to another node. So this should allow much more queries to target only the partitions that they're interested in. So definitely huge improvements in that area. And they also mention partition-wise joins as well as partition-wise aggregates. So again, this is a post dedicated to those partition improvements. If you are using partitioning or considering it, definitely a blog post to check out for PostgreSQL 11. The next post is Death by Database, and this is from the ovid.github.io blog. And it's basically kind of like a parable and a story of working with someone who had a particular data model for their application and how that data model essentially constrained what they could do and all the workarounds that would have to be done to be able to make it work they wanted it to, just because of how the database was modeled. So basically, the post is emphasizing really thinking about your data model and doing proper database design. Now, related to this, there's a linked YouTube video. It's a presentation that's approximately 45 minutes in length called How to Fake a Database Design by Curtis Poe. And I definitely suggest you checking this out if you're a developer and wanting to learn more about database design. I really like some of his key concepts to keep in mind when you're doing it. So this was a great piece of content to check out. The last post is Correlation of PostgreSQL Columns Explained. So basically, this is explaining that after you analyze a PostgreSQL table, the distribution statistics are located in the pgstat system view, and there's a correlation column. So what is it correlating? Basically, how well does the order you want in the index match the physical ordering of the data on the table? And he describes this as the logical ordering versus the physical ordering. And a perfect correlation between that would be a 1 or a -1, depending upon the order. And a 0 means there is no correlation. So basically, if you're using a sequence for a primary ID, that primary key index that generally gets created should have a perfect correlation, because all new data coming in has an increased index number that should be perfectly correlated with a ordered index. Whereas if you have random data being inserted into a value and you have an index on that, there's probably no correlation at all between the index and where the data is located in the heap. Now he mentions, why should I care about this? Because when you have a good correlation, you're going to get faster response times for your queries generally, because there's only one place in the heap it has to pull it out, and doing a sequential retrieval of that data should be faster than having to do random I/O all over the heap area. Now he does an example here where he's creating two tables, one with a high correlation and a low correlation. So going back where you have an index and just a series of numbers, you see the correlation is 1, whereas when you are randomly ordering data in an additional table he's creating, the correlation is essentially close to 0, which means no correlation. And you can see the different execution times when querying those tables. The correlated table returns in 1 millisecond, and the uncorrelated returns in 2.7 milliseconds, so more than twice as slow. Now, are there some things you can do in order to increase your correlation if you're really interested in speed? And he mentions some of this at the end of the post. If you need to efficiently scan bigger portions of an index, it's good to keep the table in index order. However, there are no index ordered tables in PostgreSQL. However, a high correlation column can be maintained in two ways. First, he says automatically, where table rows are sorted in logical column order and there are no updates or deletes on the table. So the physical ordering should be identical to the logical ordering. So again, this is the example I mentioned where you have a primary key columns generated by sequences, or perhaps with timestamps. And the second way he says is via clustering. So you can use the cluster command to actually rewrite a whole table so that the physical ordering is identical to the logical ordering. But again, if you're having updates and deletes, it's going to alter the order of that. So if you're really looking to push the performance, this is definitely something you may want to potentially consider, particularly if you have a large analytical database or maybe a data warehouse and you have more flexibility in terms of ordering data in the table. This might be something to consider. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you could subscribe via YouTube or iTunes. Thanks.